In this video, we'll be taking a look at CADfix for Plant and Process Simplification, or CADfix PPS. We have a couple of slides to start, and then we will take a look at the software in action to demonstrate how you can achieve significant file size reduction of large CAD equipment assemblies to accelerate the integration of these problematic CAD models in applications downstream. Let's start with the need to simplify. When engineers and designers integrate equipment models into plant and process layout systems, they often run into extremely large CAD files with too much detail. And this becomes increasingly problematic when integrating many MCAD equipment models into the same plant layout with large amounts of data accumulating quickly. The ability to remove unwanted parts and features and convert complex geometry into simpler representations can significantly reduce complexity and file size, and enables seamless integration into the overall plant layout. CADfix PPS has a suite of simplification tools, allowing users to rapidly reduce complex MCAD files into lightweight and manageable models. The tools retain important aspects of the models, such as their general shape and volume, but remove surplus details. The tools include the removal of small parts, such as nuts, bolts, washers, and small brackets, the removal of small CAD features, such as holes and protrusions, the removal of hidden internal parts, and the conversion of complex parts into rudimentary representations comprising of boxes and cylinders. All of these tools can be employed through the interactive toolset, giving the user close control over the process, or by utilizing the fully automatic wizard to minimize user interaction. Let's have a look at how we can use some of these tools to simplify a few models in CADfix PPS. The first model that we're going to take a look at is this 45 megabyte step file. So we'll import it and shade it, and then have a quick look around the interface. Whilst the model is importing, CADfix prepares the model for simplification, fixing issues with the underlying definitions of the geometry to ensure sort of effective and efficient tool usage. For the first model, we'll look at some of the interactive tools so we can see the sort of effect of each individual tool. And then in the second video, we'll look at how we can use these automatically. So looking at the interface in the top right here, we've got this percentage reduction of phase count that sort of shows the data reduction. In the top left, we've got our automatic tools. Just underneath that, we've got our sort of suite of interactive tools, and that's our first video. And then underneath that, we have all our exports. So let's just jump right in. And the first tool we're going to look at is the Remove Small Bodies tool. So it's very efficient and effective, and it can remove a large amount of data from the model. All we have to do is specify a size tolerance, and CADfix will automatically remove bodies underneath that size. The size tolerance can be entered directly, or we can use the measure tool to sort of select a couple of components on screen that will return their size, and we can sort of find an appropriate value using that. And then we just hit find, it will highlight all those components on screen, and we hit fix. And here we found 126 small bodies, and removing them from the model, we've removed 43% of the faces. And as you can see, the model looks very similar to before, but we've already removed a large amount of data. The next tool we'll look at is the Remove Holes tool. We have a few more settings here for hole type, shape, and size. So, you sometimes have big holes that people could fall down in plant layouts, but we just want to look at small holes here, sort of left behind by nuts and bolts. So we hit find, and all of these holes are shown on screen, and you can see here we also have sort of structural cavities inside this piece of equipment, as well as all the small holes. And this is a really good tool for things like pipes as well, where you think half of the faces of a pipe are on the inside of a pipe. You can remove a lot of data that way. The next tool we'll look at is the Remove Protrusions tool, which includes features such as embossed text and logos. So again, we'll hit find, and the selection will be displayed on screen. And we can see here we found 79 protrusions. So we'll zoom in on some of this embossed text, and this can actually carry quite a significant amount of data. If there's lots of text, there's a lot of additional phases here which we don't need. And again, we just hit fix, and it sort of wipes that from the surface. And as you can see, we've now removed 55% of the data. Some more sort of gross simplification tools here as well. The first is box simplification. So we can convert bodies into boxes. Here we're looking for components that are sort of approximately cuboidal, but contain extra details and intricacies on their surface. This will create boxes based on the bounding box size of the bodies, so that the size of the component is maintained for things such as clash detection and space management, but with a fraction of the data. So we just selected a few here and turned those into boxes, and as you can see, there were some intricate components there, and we've managed to remove a lot of detail, and our phase count reduction has gone up to 72%. And finally, for this video, we'll look at cylinder simplification, very similar to before with the boxes. But this time we're looking for things such as motors and shafts and gears and sprockets to turn those into more basic cylinders. If you think we're trying to get rid of faces, things such as these gears contain a lot of extra detail, and we can simplify these quickly by selecting them into more rudimentary just cylinders. If I wanted to simplify this model further, there's a lot more we could do. We could go around and select more components and simplify them manually one by one. But now, for now, I'm going to export this back to step, as that's how we read it in, and we'll compare the data reduction. So the new file size, exported step file size, to our original 45 megabyte step model. So the export's complete. If we open up our file browser, we can see here we're looking for this suffix of underscore CF. It shows us our process model, and we can see we've gone down from 45 megabytes to 10 megabytes. So now let's open up a new model and see how we can replicate this process using the automatic simplification wizard. So here we have a 62 megabyte step file. This time we can open up this FBM, which is CADfix's own file format. They're created after import, and it allows us to sort of save our simplification work and resume it later, and also means we can skip the import process. Taking a look at the model, there's some clear candidates for simplification. There's lots of complex parts, some small bodies, and lots of holes here. These complex parts, look like ideal candidates for cylinder simplification. You can see on the right there's some boxes and lots of small holes and small bodies. So in the automatic simplification wizard, in the top left of the screen, we've got these three levels, and these sort of dictate the tolerances, but we can also edit these tolerances manually by opening up the options window. Using the checkboxes on the left hand side, we can turn tools on or off, and on the right we can set tolerances for the active tools. So we can either enter values directly, or as before, we can use the measure tool to sort of get a feel for the size of things in the model and return them. Once we've determined the tools and tolerances that we want to use that are appropriate for our models, we can save these configuration files, and these can be loaded when we're processing models later on interactively via the interface, or also utilized in batch processing. So here we'll just save our CWC file and we'll call it auto1. Now all we need to do is press apply, and that will begin the simplification process. The progress monitor sort of relays where the process is up to. For the purpose of this demonstration, I'll skip ahead to the end of the processing, but we'll highlight the time that it took on screen. So the processing's done, and as you can see, the process took 215 seconds, so that's about 3.5 minutes. And in the top right, we can see we've removed 74% of the faces in the model. So 3.5 minutes and, around a high 70, 80% reduction in data probably. And looking at the result, we can see how the box and cylinder simplification has sort of intelligently determined appropriate candidates for simplification. The model has retained this outer envelope. It's obviously visually recognizable as the model which we read in, but with a significant reduction in the total data. And again, we'll export a step here. So this process will just take a minute, and then we'll compare it in the file browser. So if you highlight these two models in my file browser, we can see now this time we've gone down from a 62 megabyte file to an 8 megabyte file. So that's a high 80% reduction, and that's really good, and that's sort of typical of what you'd see. Now we know how to save a configuration file containing our required tools and tolerances. We can simplify multiple CAD files in a fully automated batch process. So if we go to our file browser to open a model and go to multiple files, we can populate a list of all the files that we want to simplify. And all we need to do is load in that configuration file. So the auto1 CWC that we created in that previous run, and then run the wizard. And that's all we have to do to process multiple models using configuration files that we've already determined as appropriate for our models. And that's as simple as it is. It's really easy to do this to multiple models. As before, the progress monitor will keep us updated on the progress of the batch process. And as before, we'll skip ahead here and just take a look at some of the results and the file size reductions. So once the processing is finished, we're shown a report of the processing for each model. Each model has its own log files to summarize the processing. And from the wizard report, we can open up the log files, or we can select a model and open that model up for interactive processing, or just to have a look at some of the results. So we'll open up a model here and see what it's done. And obviously we won't be able to see the original model, but we'll probably be able to see with some of the where the model has been processed, and also the file size reduction. So if I share this model, we can see some areas where we've converted into cylinders and boxes. That's quite clear. There's sort of the absence of small holes for some of your cylinders there. This motor here has been turned into sort of a series of boxes and cylinders, probably greatly reducing the data if it has like cooling fins. And yeah, obviously the absence of small bodies and holes is apparent as well. And you can see in the top right that we've removed around 3/4 of the faces. And if I go into the file browser, we can see all our original files and all our simplified ones, and we'll highlight these. And we can see that we're consistently achieving a data reduction of around 80% for these models cumulatively. If I highlight all of these, we've gone down from around 137 megabytes to around 28.5 megabytes, and that's a really good reduction. So this video is just meant to provide some quick insight into CADfix PPS and how it can be utilized to achieve rapid data reduction of complex MCAD assemblies. I hope you enjoyed this video. And if you want to check out CADfix PPS, register for a free evaluation at the link on this slide.